Hey guys, this is Mrs. Harbin and this is Advanced Math. Today we are going to look at part 2 of our factoring unit. Let me apologize in advance for the dog in the background. We are stuck inside today and he is looking out the window and barking at everybody that goes by. So just try to tune out the dog in the background. Alright, so section 2 of factoring. Let's start with a quick lesson opener and review how to multiply binomials. Hopefully you remember that we can multiply a couple of different methods, but basically we're going to multiply the first times the first times the outside terms, the inside terms, and then the last terms. Okay, our acronym to remember that is FOIL. Some of you may not like to do it that way, and you may prefer to set it up like a traditional math problem, where we have x plus 1 and x plus 2 being multiplied like that, and you multiply this term and then this term, and then you scoot over, leave a space there for your placeholder, and multiply x times 1 and x times x. Or some of you have seen the box method, and you may prefer to do the box method, where you multiply x and positive 1 and x and positive 2. And then you multiply what's in the boxes, where the row and the column meet. So here you would multiply x times x. Here you would multiply x times positive 1, and then you combine like terms. So whichever method you prefer, go ahead and do that, and then let's check your answers for each of these problems. For the first problem, we get x squared plus 3x plus 2. For the second, we get x squared minus 4x minus 21. For the third, we get x squared minus 2x minus 24. For the fourth, we get x squared minus 8x plus 15. And for the last, we get 6x squared plus 10x minus 4. Now, if you missed any of those and you're not able to figure out what you did wrong, make sure you write that down in your notes so that you can see me in class and we can review how to multiply binomials again. Now let's talk about factoring. Factoring is just the opposite of multiplying. While we were multiplying binomials to get a quadratic, now we're going to take a quadratic and work in reverse and factor to get back to two binomials. So let's talk about how to factor x squared plus bx plus c, which is our standard form for a quadratic. We know that when we have x plus 5 and x plus 7 being multiplied, we end up with 12x and 35. If you look at that, do you notice any relationship between 5 and 7? Hopefully you notice that our middle term, when we multiply our constants here, our 5 and our 7, our two constants add up to our middle term. So this middle term is the sum of the constants 5 and 7. And our final term there, our 35, our constant term, is the product of the constants 5 and 7. And so if you notice that pattern, then working backwards to factor that instead of multiply it can be helpful. So the first thing that we want to do is write the factors of the first term. Our first term is x squared. Then we want to find factors of the constant term, c, whose sum is b. So we want to find two numbers that when multiplied equals c, but when added will add up to our b term. So a number times a number equals c, and those two numbers need to add up to b. We're going to write these factors as the last terms in our binomials. We'll check the results by multiplying to make sure we end up back at our original equation. So here's an example for you. Let's factor x squared minus 5x plus 6. The first thing that we want to do is write the factors of x squared as the first terms in the binomials. So we're going to put our parentheses for our binomials and write the factors of x squared, which are x in x, as the first terms. Then we want to find two factors of 6, positive 6, whose sum is negative 5. Well, when we think about the factors of positive 6, we have positive 1 times positive 6, positive 2 times positive 3, or negative 1 and negative 6, negative 2 and negative 3. Those are all the factors. If we were to multiply each of those, they would equal a positive 6. Now, only one of those has a sum of negative 5. And that is our negative 2 and our negative 3. So we're going to write those as the last terms in the binomials, x minus 2 and x minus 3. We can check by multiplying. If we multiply that back out, we get x squared minus 2x minus 3x plus 6 which when combining like terms simplifies to x squared minus 5x plus 6. Exactly what we started with, so we did factor correctly. Let's try a second example together. Let's factor y squared plus 5y minus 6. The first thing we want to do is take our factors of y times y, and write that as the first terms of our binomial. Then we want to look for factors of negative 6 that add up to a positive 5. Our factors of negative 6 are positive 1 and negative 6, or negative 1 and positive 6. Positive 2 and negative 3, or negative 3, positive 3 and negative 2. Okay, which of those adds up to positive 5? Hopefully you notice this pair is the pair that adds up to positive 5. So we have 6 and negative 1. We're going to make those the last two terms, or the last terms in our binomials. So we have y plus 6 and y minus 1. We can check our work by multiplying that back out, and we do get our original equation. Now hopefully you noticed something, a pattern, about determining the signs of the factors of c. If the sign of c is positive, like when we had positive 6, what does that mean about our factors? It means that the factors are going to have the signs that are the same. So we have positive 1 and positive 6, for example, or negative 1 and negative 6. The signs have to be the same so that when they're multiplied, they equal positive 6. The factors will also have the sign of the trinomial's middle term. So if our middle term is a negative number, like a negative 7, then they're going to have that negative sign. If the sign of c is negative, like when we had negative 6, then the signs are different. We had positive 1 and negative 6, or we had negative 1 and positive 6, for example. So the signs will be different, and the larger factor will have the sign of the trinomial's middle term. Our middle term in that one example was positive 5, and our larger factor had the positive sign there, positive 6. So that's just a little helpful tip, a little pattern recognition there when you are factoring these quadratics that have a leading coefficient of 1. Let's put all that to use now and factor x squared plus x minus 72. The first thing that we're going to do is split our x factors so that they're the first two terms, or the first terms of our two binomials. Then we'll find two factors of negative 72 whose sum is 1. So we need a positive and a negative number that when multiplied equals 72, and the larger of the two numbers is going to be positive because the sum is a positive 1. Hopefully you thought of positive 9 and negative 8. We'll make those the last terms in our two binomials, and so this factored is x plus 9 times x minus 8. If we were to FOIL that back out, we would get x squared minus 8x plus 9x minus 72. And when we combine like terms, we get x squared plus x minus 72, which is exactly what we started with. So we did factor it correctly. On your own, try to factor x squared plus 3x plus 6. See if you can figure that one out, and then come back and check your work. Like before, we're going to take our factors of x and put it as the first of each of our two binomials. We're then going to look for two factors of 6 that when multiplied equal positive 6, and when added equal positive 3. Both of our numbers here need to either be both positive or both negative. Well, if you think about that, there are no such factors. Our factors of 6 either add up to positive 7 or negative 7, positive 5 or negative 5. Nothing adds up to a positive 3. There are no such factors, so we say this is unfactorable, or we say it's prime. Unfactorable or prime. The first step in factoring a polynomial is to factor out any common monomial factors. When the constant term is a large number, a more organized approach may be helpful. Let's take a look at this example. 2a squared minus 64a minus 288. Now, we can't just split our first term like we've been doing. We can see that each of these has a 2 that can be factored out. So the first thing that we want to do is factor a 2 out of our equation, out of our quadratic or polynomial. When we factor out a 2, we're left with a squared minus 32a minus 144. From there, we can then follow the steps that we've been following. Split into two binomials, take our factors of a and make those the first terms, and then find two factors of negative 144 that have a sum of negative 32. The two factors of negative 144 that have a sum of negative 32 are positive 4 and negative 36. So we'll put those as the last terms of our binomials, a plus 4 and a minus 36. It's still wise to check your answer by multiplying. What we would do is FOIL this, so first, outside, inside, last, and then we would take all of that and multiply the whole thing by 2, and we would end up back at our original polynomial. Some trinomials contain two variables. When factoring a trinomial of the form x squared plus bxy plus cy squared, be sure to include a factor of y in the second term of each binomial. Let's take a look at what that looks like. We want to factor x squared plus 11xy plus 24y squared. The first thing that we want to do is split our x factors, xx, but in this case, we also want to split our y factors into the second term of each binomial, y times y. From there, we want to find two factors of 24 whose sum is 11. 3 and 8 when multiplied equal 24, and when added equal positive 11. So we're going to rewrite that as x plus 3y and x plus 8y. If we multiply that right back out, we do get x squared plus 11xy plus 24y squared. Again, we always want to check our work just to make sure we didn't make any mistakes with our signs. If you guys have any questions about how to factor these quadratics, how to factor out monomials, or how to factor a quadratic or an expression that has two variables, make sure you write down those questions and ask me next class.